আছে না দুটো এখন কটা হলো ওখানে কিছু বলেনি Good morning all of you. In today's session of class 9 physics we are going to start the second part of the chapter laws of motion. So we are going to start Newton's second law. Okay, so the thing is that today we will discuss one topic, that is linear momentum. So we will discuss the topic linear momentum. So actually any body which has got a mass and a velocity, any body it has got a mass and a velocity. So the product of mass and velocity is called momentum, and momentum the symbol is P. So you are aware that mass is a scalar quantity, like mass doesn't have direction, but velocity is a vector, velocity has got direction. So the direction of momentum will be the same as the direction of velocity. So momentum is mass into velocity, and momentum and velocity both will have the same direction, right? Okay, what is the SI unit of mass? 1 kg. What is the SI unit of velocity? 1 meter per second. So the SI unit of momentum is 1 kg meter per second. Okay, one, or rather you can say that kg meter per second. This is the SI unit of momentum. Okay, it is kg meter per second. Now the fact is that momentum plays a very important role in Newton's second law, and it plays a very important role in Newton's second law. So I'll just tell you that what is it about momentum that plays a role in Newton's second law. Actually, the momentum itself is not so important, the change in momentum. Now, change in momentum, we write it like this, delta P. So that is delta mv. Now, usually, like m is a constant. So in that case, it will be m into delta v, because m is a constant usually. But what happens is, according to Einstein, if an object is traveling at a speed which is very high means greater than 10 to the power 6 meter per second. So if an object is traveling at a very, very high speed, so you normally for bodies all around us, etc., this is not expected. So such a high speed you can probably get in subatomic particles. So if the speed of the body is more than 10 to the power 6 meter per second, then the mass will not be constant. Mass will be m0 by root over 1 minus v by c whole square. So in this formula, m0 is called the rest mass. Is called the rest. So according to Einstein, when you say change in momentum, so either you can say for almost everything in day-to-day life, whatever we see, we call them macroscopic as opposed to microscopic. So mass is constant. But otherwise, if you are talking about particles smaller than an atom, there are certain instances where the speed can exceed 10 to the power 6. In that case, the mass doesn't remain constant. The mass is rest mass. Rest mass means when the velocity of the object is 0, so that is called rest mass. So rest mass divided by root over 1 minus velocity by c whole square. So this is the formula. So this is all we are going to do in today's session. In the next session, we will actually do the Newton's second law. Meanwhile, as always, I am giving you the homework. Okay, the third question is unit of momentum. Options are Newton second, kg meter per second square, Newton per second, kg square meter per second. So you have to identify which of these is the unit of momentum. So these are the three questions, and you can submit your homework by 9 p.m. tomorrow. So that will be all for the time being, and I will end the session now. Bye all of you.